Hi everyone, so in this video we are going to solve this assignment. So let me show you the question. This is the first one, then this is the second one. These are GATE PYQs only. And this I told you I will discuss in the assignment. So this is the third one. This is the fourth question. This is the fifth, that this is a voltage doubler circuit only, and while teaching it in the conceptual video I told you that I will tell you how it behaves in one cycle. Then in another cycle it will behave differently, then another cycle, and then it will reach to steady state. So for one cycle we will see it, and if gate ask you, they will ask you only for one cycle only, so that we will see. And then we will see this question. This will test your transient analysis and signal system rather than analog electronics, because the use of diode is very low here. You need to find the I average value. This is the question. If any other question is there, yeah, then this very straightforward question. This is a gate PYQ only, this question. Yeah, so that would be it, I guess. We will solve these questions. So let's start from question number 1. Very straightforward question. I just picked this question to let you know that this is a very straightforward circuit. You have studied it, but still you are not able to see it. This is a voltage doubler only. Look, one end of battery is connected to ground, other end to capacitor. Then this end of capacitor is connected to diode, the other end of diode is connected to ground. Then there is N side of this is connected to diode, then the other end of diode is connected to this battery, and other end of capacitor is connected to ground. This is a voltage doubler only. This is 1 microfarad and this is 0.5 microfarad. This is D2, this is D1, and this is Vin. What this will do, it will clamp up, and what this will do, it will detect the peak. So what will be the output? 2 Vm. 2 Vm, that means 2 into 50, 100 volt, sorry, not watt, 100 volt. So this is the way. And even if in the examination you couldn't understand what kind of circuit is that, so how you would have solved? I told you one thing, you need to turn on this one. So it will turn on at minus Vm, and it will charge the capacitor in this direction. So this capacitor would have charged to plus Vm, like that. Then what will happen? From here, V in plus Vm would come. V in plus Vm would come. So to turn on this diode, we will see the maximum supply. So 2 Vm we will see. Then this diode will turn on and it will charge the capacitor in this direction. So this will be charged to 2 Vm like this. So VAB would be 2 Vm, and 2 into Vm would be 50. 2 into 50, that means 100 volt will be the answer. So even if you are not able to recognize the circuit, still you can solve it, because we have seen a lot of examples. I guess around 25 to 30 examples we have seen. Not that much, but 20 to 25 examples we have certainly see for voltage doubler, tripler and quadrupler, right? So you will be able to solve it. Yeah, then let's move on to the next problem. This one, this is also very easy. It seems like that they are looking for some voltage. What is that? It kind of feels like a negative clamper, but it's not negative clamper. This is a simple transient question only. So what is happening? First, plus 14 is coming. So here the supply input is plus 14. They are saying that this time window is very high. That means this time window is very high. So plus 14 is there for a very long time. So the capacitor have enough time to charge and discharge. They are saying that this time window is very high. That means tau is very low. Tau is very low. Tau is very low. That means capacitor have enough time to charge and discharge. This is what they are saying. Now what you would think at the first sight, that you will think that now this capacitor will start charging, so output will go down. You will think that output will go down, because at the steady state, if capacitor is open, the output will be at 0. So the capacitor will start charging and output will go down. This is what you would have thought. But at t equals to 0 only, what will happen? At t equals to 0 only. At t equals to 0. V in is 14. V in is 14. At 0 plus you can say. V in is 14. V capacitor will be 0 volt only. Capacitor voltage will not change instantaneously. That's for sure. So at 0 plus it will change actually. So you can say at 0 only. So this will be 0 volt, right? So now this 14 volt will reach here. 14 volt you have applied, there is no charge on the capacitor, so this 14 volt will reach here. Now if this 14 volt reach here, so it has the ability to turn on this diode D1 and this Zener diode D2. So this diode D1 will be replaced with a 0.7 volt battery and this will be replaced with a 6.8 volt battery. 14 you applied, this 14 reached to the diode D1 and D2. D1 turns on and D2 goes into breakdown. What happens? D1 turns on and D2 goes into breakdown. So this gives you 0.7 and this gives you 6.8. 6.8 plus 0.7, that means this will give you 7.5. So basically from here you get 7.5. So in first cycle itself 0.7 and 6.8, 7.5. So here you had 14 and immediately at the other end you are having 7.5. So this is your capacitor. This is your capacitor. At this point you are having 14 volt and immediately here you are having 7.5, that is fixed. Now this is fixed. Until 14 volt is there, this potential is fixed. So now there is no one which can change the potential of capacitor. So this potential of capacitor will be 6.5. So immediately capacitor is charged to 6.5 volt. So if we draw the VC waveform, how it would look like? We are drawing the VC waveform. So till time t by 2 we will draw. So till time t by 2, what will happen? First it was 0. This is the VC waveform we are drawing. Then suddenly it is reaching up to 6.5. 6.5. This is the VC waveform. .5 volt. And what about V naught? V naught is also reaching up to 7.5, that is fixed. V naught is also 7.5, which is fixed, and that is there till time t by 2. Which is 7.5 volt. Well and good. Now what is happening? At t equals to t by 2 plus, V in is minus 14. V in is minus 14. Now this capacitor is charged to 6.5 volt. There is no one which can change this. So this capacitor is charged to 6.5 volt. Now suddenly this input is minus 14. If this is minus 14, then this potential would be minus 14 minus 6.5. That would be minus 20.5. Now if this is minus 20.5, then D1 will be off and D2 will also be off. Both will be off. Both will go into reverse bias. Minus 14, the capacitor is not changing its voltage instantaneously. Minus 14, minus 6.5, minus 20.5. D1, D2 both will go into reverse bias. So both will be off, right? What is happening? V in is minus 14 and then D1 and D2 both are off. Now if D1 and D2 both are off, what will happen? This is how the circuit will look like. This is capacitor C, this is resistance R and C. This is charged to 6.5 and this is your V naught. And here you have applied, this I can say ground, here you have applied minus 14 volt. So immediately your output is going to minus 14 minus 6.5. So your output at t by 2 plus would be what? Your output at t by 2 plus would be minus 14 minus 6.5. That would be minus 20.5. Am I doing the calculation right? Okay, 14 7.5, that means 6.5. Okay, 6.5, then minus 14, 14 minus 20.5. Yeah, so immediately your output is going to minus 14.5. At steady state, what will happen? Because since RC is very lesser than time period, that means you have enough time for the capacitor to charge and discharge. So the capacitor will be completely charged. So at steady state, what will happen? This is VC. Now at steady state, since this is minus 14, that means capacitor will charge in this direction. So at steady state, VC will be charged up to minus 14 volt and your output will be 0 volt, right? At steady state, capacitor will be open circuited. The simple thing is, at steady state, what will happen? Your capacitor will be open circuited. That means your V0 will be 0 volt, and what will be your VC? VC will be 0 here and minus 14 here. That means VC will be minus 14. So since RC is very low, you have enough time to reach steady state. Enough time to reach steady state. Let's add up a page. Here only we can write V0 at steady state will go to 0 volt, and VC, which is currently at 6.5, at steady state it will go to minus 14. So we can draw the final waveform. I will just copy this diagram. Both of the diagram I can copy together. It will decay exponentially and it will go till minus 14. It will decay very fastly actually, right? Because it will reach the steady state very quickly because time window T is very high. This time window T is very high. So it will reach till minus 14. This is time T. And what about V0? V0 suddenly changed its voltage to minus 20.5. Minus 20.5. But from here it will go to 0. Let's take this time is time T. Well and good. So here it will go to 0. So what they asked the maximum and minimum voltage. So maximum voltage of V0 is 7.5, minimum voltage is minus 20.5. Maximum and minimum voltage. Although in the examination you could have solved it in just 1 minute only, but I show you the complete concept. What if they ask you waveform? What if they ask you any other thing? So anything if they ask you from this question, you would be able to answer. But in the examination, they just ask you maximum voltage 7.5, then the minimum would be minus 20.5. That's it. Let's move on to the next problem. So this was a good problem. I wouldn't say very good problem. The very good problem we have already solved in the lecture, right? That average diode current. But here it was actually a simpler problem. So triangular input is applied, then diode is there, the capacitor is there. Instead, in the load, instead of resistor, there is a current source. Ideal current source is there, and then you have to find the ripple. So let's solve this problem. I will make the circuit. I will pause the video and make the circuit. Yeah, so this circuit was given. This is your input waveform, plus 10 to minus 10, plus 10 to minus 10, plus 10 to minus 10, and yeah, then you have to find the ripple. So how the ripple is coming, everything we will see. So what happens when Vin is positive, this diode will be on. When Vin is positive at t equals to 0 plus, diode will be on. Now people will say that sir, it is starting from minus 10. Why did you start from 0? You can start from anywhere. If it is starting from minus 10, then minus 10 to this point, the diode will not even turn on. From minus 10 to 0, the diode will not even turn on. Nothing will happen in the circuit. Right? If diode is not even turning on, this current is flowing through the capacitor, which can charge up the capacitor in the opposite direction. But let's not, they are just looking at the steady state. Let's not worry about that. They are looking at the steady state only. So at steady state, some ripples are there, and that we need to find. That's it. Nothing else. So that's why I started from here. So what is happening? Diode is on. So If diode is on, what will happen? The complete input is exposed to the capacitor. So this I am drawing output. So output I am drawing in the white pen. Output I am drawing in the white pen. So what will happen? The capacitor will start following the input. This is how it will start following the input. Now till we have reached to time t by 4. So at t equals to t by 4 plus, what is happening? Your input will be 9.9 volt. And what will be your V naught? Your V naught will be 10 volt only. This we are assuming it, right? Because this is how we solve it. So at the next moment, your input is low, but your out here your capacitor is having high voltage. 10 here, 9.9 here. That means diode will be off. Now the diode is off. Since the diode is off, now what will happen? Tell me. Diode off. Now in the previous example, what was happening? Here there was a resistor. So the capacitor was discharging because of the resistor. But now there is a current source. Now there is a current source. So what will be the circuit now? Circuit will look something like this. That you are having a capacitor and you are having a current source which has the value of 1 ampere. And this 10 volt is already there. This capacitor is 475 microfarad. Now this 1 ampere current is flowing in the capacitor like this. So it is charging the capacitor in the opposite direction, in this direction, in this direction. That means it will charge the capacitor like this. So if I am assuming this as V naught, this as V naught. So what will happen? The V naught will go down because the current is flowing from down to up. But V naught I am taking from up to down. So what will be the equation of V naught? V naught will simply be 10 minus, what is Vc? What do we remember? I equals to C dVc by dt. So Vc is 1 by C integration Ic dt. From you can take minus infinity to time t. But if Ic is constant, then what will be Vc? Vc will be Ic into t by C. Right? This we already remember. Ic is constant here. The current is constant. In RC circuit, what happens? The current keeps on changing. In this kind of RC circuits, what happens? Initially the current is 5 by R, then this capacitor is charged to, let's assume, 0.1 volt, so the current will be 4.9 by R. If this capacitor is charged to 0.2 volt, the current will be 4.8 by R. So with time the capacitor is charging, so the current in the capacitor is changing. That's why their exponential response is there. But here 1 ampere current is fixed. So if the current is fixed, then the capacitor voltage will be ICT, current by the current into time by capacitance. So current is 1 ampere, T by 475 micro. But instead of T, I will write T minus T by 4 because we are starting from T by 4. So T minus T by 4. Instead of T, I am writing T minus T by 4. Why so? Because we are starting from T by 4. From here we are starting. Na? So that's why I wrote. So this is V naught T. This is my V naught T. So basically V naught is dropping. My V naught is dropping. Then it will drop. Then at one moment you will realize that the potential has, this capacitor potential, let's assume it has dropped and it has reached to 8 volt. So here you will realize that the next moment potential will be 8.1. So what will happen? Again the diode will be on. If the diode is on, again the complete input voltage is exposed to the capacitor. So the capacitor will follow the input voltage. So this cycle will keep on going. So as the time when input is more than the capacitor voltage, it will follow the capacitor. Then it will reach there, then again it will go down like this. Again it will reach there, then again it will go down like this. So now what they want us to find? They want us to find from here to, okay, this, अरे यार ये स्ट्रेट लाइन नहीं आएगा. This much of gap they want us to find. This much of gap they want us to find. This gap they want us to find. They are calling it micro U. U they are calling it. How would you find this gap? Look, one assumption we will have to take. The assumption is that it is decaying, I know. What is this time? First tell me what is this time? This time is 5t by 4. 5t by 4. And now it is decaying t plus t by 4, 5t by 4. I know this has started decaying from time t by 4. It has started decaying from time t by 4. And before 5t by 4, it has decayed. After that, it is following the input. But we have to take the assumption that from t by 4 to till 5t by 4, it is decaying. Look, this time is very, very less. Here you can see this time is very, very less. Look, it starts decaying from here and it decays till this point it decays. Then again it follows the input. You know this time, this is t by 4. You know this time, that is 5t by 4. This time is very near to 5t by 4. This kind of example we already saw in the lecture itself, where we take the assumption that it has decayed till 5t by 4. Although it hasn't decayed till 5t by 4. थोड़ा सा पहले तक डिके हुआ है, उसके बाद इनपुट को फॉलो किया है. बट वी हैव टू टेक दिस assumption that for a time window of time t, it has decayed. Right? This assumption we need to take. So let's assume this potential is 10 volt and then I would get to know that how much it has decayed in time t. Let's assume this potential I found out to be 8. Then what will be the ripple? 2 volt. That's it. I just need to find out in time t. So in this period, what is happening? The diode is off. In this period, diode is off. So in this period, what will I find? The capacitor is discharging because of the current. So because of the current, where the capacitor is reaching, because of the current, the capacitor is reaching, let's assume to 8 volt. That means from 10 to 8 it has reached. So what is that width? 2 volt. That would be my answer. So I need to find, I will write down that here diode is off. So here diode is off. So in this window, this current source is in action. This current source is in action. So what will be your V0 potential at 5t by 4? Nearly 5t by 4 I will write, or 5t by 4 minus I can write. So that would be t minus t by 475 micro. What is the value of capital T? That must be given in the question. Time period of 1 millisecond. So that is 1 millisecond. So 10 minus 1000 micro divided by 475 micro. It would be nearly 2.1, right? 2.1. So here you get 7.9. 7.9 volt. So V0 at 5t by 4 minus is, you are getting 7.9 volt. So this potential here that you are getting is 7.9 volt. I should make it on next page. What was happening? Here it was 10 volt, then it was decaying to 7.9 volt, then it was again following the input, then again it was decaying, and again it was decaying, then again it was following the input, again it was decaying. So here it was 10 volt. Now it has decayed up to 7.9 volt. So what is this ripple? What is this gap? This gap is this value, 2.1. This is U. So U is 2.1 volt. That's it. That's the answer. Nothing else was asked. Okay. No concept of diode circuit. Nothing is used here. Diode is on. It is following the input. Off, decay. Then suddenly again on, again decay. So from here to here it has decayed because of the current source. If it was decaying because of the RC, we would have written an exponential equation. But then we take an assumption that even in the RC, if RC value is very low, if RC value is very high, that means we can take an assumption of e to the power minus x, we can linearize to 1 minus x. So that also becomes as a current source only. Because in the current source, the decay is linear. In RC, the decay is exponential. But if the RC value is very high, We can approximate it to linear only. These kind of example we have already solved in the lecture itself. So just I am making you remember what we have solved. So now you can relate, right? So now you can solve this question very easily, 2.1 volt. Let's move on to the next one. This is actually a very easy question, but many of the students got it wrong. So we can assume ground anywhere, always assume the ground nearest the supply. Okay. So what will happen when positive cycle will come? So when positive cycle comes, so this D1 will get on, basically 10 volt will come here. This is 0, this is also 0, this is also 0. When Vin is plus 10 volt, then what will happen? D1 is also on, D2 is also on. So now this capacitor will be charged in this direction. This capacitor will be charged in this direction to 10 volt. To 10 volt. And then this capacitor is charged in this direction to 10 volt. Right? What they are asking, the RC product is very large compared to time period of AC voltage. Assuming the diode does not break down in the reverse bias, the output voltage V0 at the steady state is. Okay. So what we got to know, when steady state output they are asking, so we will take plus 10 and minus 10. Steady state output they are asking. So when Vin is plus 10 volt, look, you can solve it for a cycle as well. Like let's solve it for the complete cycle. No, let's not take it like that because people will get confused. Yeah, so our input is 10 sin omega t, right? So let's take for 0 to t by 4. First I will make the input 10 sin omega t. This value is 10. This is t by 4. And this is complete time period t. So for 0 to t by 4 we are taking. What will happen? Vin is positive. And if Vin is positive, that means D1, D2 both are on. D1 and D2 are on. So both capacitor charges. Let's call this one as C1, this one as C2. So both capacitor are charging. Let's call, let's remove it. Okay, remove complete. D1, D2 both are on, you got to know, right? When positive is there, D1 is on, D2 is also on. Both capacitor will charge. Let's call this potential as VC1 and this potential as VC2. So basically your V0 will be VC1 plus VC2 at steady state. This all at steady state, right? So now what is happening? D1, D2 both are on. So this will charge and this will also charge. So now it will charge like 10 volt in this direction and it will charge like 10 volt in this direction. So till VC T by 4, I should write VC1 at T by 4 would be 10 volt and VC2 at T by 4 would be minus 10 volt. Basically, if you draw the VC1, roughly I am drawing, this will be the VC1 waveform and this will be VC2 waveform. Rough waveform we are drawing. Now after that what is happening? And here we have assumed the ground. Ground assumed is this. After that what is happening? The input voltage is somewhat less than 10. Let's assume that is 9.99. So here you are having 9.99. Here you are having 10 volt. 10 volt here, 9.99 here. That means diode D2 is off. What about this? 10 volt here, 9.99 here. That means diode D1 is off. Both diode gets off, right? So we can write it on the screen. At t equals to t by 4 plus Vin is 9.9 let. Vin is 9.9 let and VC1 is at 10 volt and VC2 is also at a minus 10 volt. So both diode D1 and D2 are off. And that is the steady state only. Why so? Because for turning D1 and D2 on, what do you need? This is the Vin potential. Vin, here you can see that Vin should be greater than 10. And here this is Vin potential. So here also you can see that Vin should be greater than 10. So for to turning on D1 and D2, you need Vin should be greater than 10, which is not possible. D1 and D2 are off. To turn on D1 and D2, Vin greater than 10 volt, which is not possible because supply is 10 sin omega t. So this is only the steady state. So steady state reached. There will be no discharging in the capacitor. Why so? Because the resistance value is very large. Steady state reached. No discharging in the capacitor. Why so? Because this R resistance value is very large. It is written there. The product RC is very large. Steady state is reached. That means VC1 at steady state is 10 volt and VC2 at steady state is minus 10 volt. What will be your V0? V0 is VC1 plus VC2. That will be 0 volt. This is your answer. 0 volt. Right? Or else in the examination, how would you would have solved it? In the examination, you would have solved it with a very easy method. You wouldn't be writing this much of complex thing. In the examination, you know that, okay, my capacitor will be charged to the maximum voltage. That means it will be charged to 10 volt. Here it will be charged to 10 volt. That's it. After that, the diode will be off only. So this is charged to 10 volt, but the direction of charging is this. And here the direction of charging is this. What they are collecting? They are collecting the output here. That means from here to here 10 volt is there, and from here to here 10 volt is there. So V0 is connected. This is plus terminal, this is negative terminal. So 10 volt minus 10 volt. That means 0 volt. That's it. In 1 minute only you will be able to solve it. You see 10 volt, this is charged to 10 volt. This potential is 10 volt, this potential is also 10 volt. 10 volt minus 10 volt, 0 volt. That's it. Right? So if you have studied the previous lecture, you would be able to solve it very, very quickly. In the examination, like people would think this will act as a voltage doubler. So it should be 20 volt, but this is not acting as a voltage doubler. If it was acting as a voltage doubler, it would have been like this. This is a positive peak detector and this would be a negative peak detector. Right? The diode should be like this. This would be a negative peak detector. So this would have charged like this 10 volt. So 10 plus 10, 20. This example we have already solved in the theory video. Right? So yeah. Everything that is going to be asked in the examination, that will be in your notes. That I can guarantee for every subject that I am going to teach, and every subject Anish is going to teach. Every single thing will be in your notes. It's not that we will later on add the things. पहले हमारे नोट्स में होगा, उसके बाद एग्जाम में आएगा, ये गारंटी दे सकते हैं. सब्जेक्ट थोड़े धीरे आते हैं हमारे, लेकिन जब आएंगे तो इतने सही लेवल पे आएंगे जो आपको दिख भी रहा होगा अभी. और नेटवर्क एनालिसिस भी आप पढ़ चुके होंगे, वो देख सकते हैं आप. ठीक है, तो या let's move on to the next one. This question, so we will solve it very slowly with good patience. So you have the patience, then we will solve this question. So you have to tell me the VC1 and VC2 value at time equals to t. So if you are not aware if your concepts are not good, what you would see, okay, this is a voltage doubler, so this it will charge in this direction. So VC1 would be minus Vm and VC2 would be, this will detect the positive value, then this is minus Vm, so V in plus Vm, so this will detect the 2 Vm. So VC1 value at VC1 value at time t equals to t is minus Vm and VC2 value at time t equals to t is 2 Vm, and this would be wrong because I told you that is the steady state. That is steady state. This is not after 1 cycle or 2 cycle. That is approximately after 32 cycle. So that is steady state. So this is steady state. This I thought that at time t goes to t, this would be the same, but this is actually steady state. Steady state, not after what's 1 cycle. So for after 1 cycle, what you need to do? You have to analyze the circuit completely. Like input is going high, what is happening, like that you need to analyze. So now we will analyze the circuit. Okay. Yeah. So let's take up this circuit on the next page. Small input is also should be there. This time is T by 4. This time is T by 2. This time is T by 2 and this time is 3T by 4. First, what is happening? Both capacitors are having no potential. No charge is there. Both are having zero potential. Positive cycle is coming. Just as positive cycle comes, let's assume 1 volt is coming. So 1 volt will come here. 0 volt is here. Because this 1 volt will close this capacitor C1 because there is no charge on that. This 1 volt is coming here, that means this diode will be off. 1 volt and 0 volt, this diode will be on. So initially D1 turns on. Okay, I forgot to give the name. This call as D1, this as D2. So initially D2 turns on and D1 is off. And till what time it will happen? At least till T by 4. At least till T by 4. After that the scene may change, but at least till T by 4 nothing is happening. The nature is same. So at least till T by 4, what do I see? The D1 is on and D1 is off and D2 is on. Are you getting this point? Initially what happened? Even just at the beginning, what happened? So when instead of writing when, let's write for 0 to T by 4. Or we should start writing like that. At T equals to 0 plus. At T equals to 0 plus. V in is positive. That means D1 off and D2 is on. So how will the circuit look like? This is VC2, this is VC1. Now this V will be equally divided between both of the capacitors, but because both of the capacitors are having the same capacitance value, so V will be equally divided between both of the capacitors. Now let's assume that V is increasing from 0 to 100. That means VC1 will increase from 0 to 50 and VC2 will increase from 0 to 50. VC1 and VC2 both will increase from 0 to 50. Are you getting this point? Let's assume my V in is 50 volt. What will be VC1? 25. What will be VC2? 25. Right? V in is 100. What will be VC1? 50 volt. What will be VC2? 50 volt. So it is increasing from 0 to 100. VC1 is increasing from 0 to 50 and VC2 is increasing from 0 to 50. So let's see it in the big waveform. So what I will write here, for 0 to T by 4, V in is increasing from 0 to 100 volt. Then VC1 will increase from 0 to 50 volt and VC2 will increase from 0 to 50 volt. This is T by 4. T by 4 I am not making a point, so let's till this point at least. Okay, this will be 50. If this is 100 volt, this is 100 volt, so this will be 50 volt. This will be 50 volt. After that, what will happen? Let's check that. So at the next moment, what do I know? That here I am having 99 volt at the next moment, right? And this is at 50 volt. And this is also at 50 volt. This I am talking at T equals to T by 4 plus. This we are talking at T equals to T by 4 plus, that here I am having 99 and here I am having 50. So here you are having 50 volt. 99 minus 50, this will be 49 volt. 99 minus 50, that will be 49 volt. Here 49 volt. Here 50 here and 49 here. D2 is also off. D1 is certainly off. There is no issue. D1 is certainly off. D2 is also off. Till what time D1 will remain off? Till what time D1 will remain off? Now what is happening? Input is going down. Both D1 and D2 are off. Both D1 and D2 are off. What will be the circuit? This is the capacitor. D1 is off, open circuited. Then there is this input voltage. D2 is off, open circuited. No current is there in the circuit, no current is there. Both capacitors are open-ended. This end of capacitor is open-ended, this end of capacitor is open-ended. Both are open-ended, no current is there, no charging, discharging will be there. Both will retain its voltage. But till what time it will retain its voltage? Look, D1 and D2 both are off. That means capacitor C1 and C2 both will retain their voltage. But till what time? That is the question. So they are having 50-50 volt. Both capacitors are having 50 volt. But input is going down. It is going down. Let's assume I am calling this as Vin only. So this potential will be Vin minus 50 because both are retaining its voltage. This potential will always be 50. This potential will be Vin minus 50. So at the time when input goes below 50 volt, let's assume my input is 49 volt. When input is 49 volt, because input is decreasing, when input goes below 49 volt, what will happen? 50 volt, that means at 49 volt, what will happen? This D1 will turn on. Will this D2 turn on? No, for D2 to turn on, Vin should increase. That means this potential at least should increase. But it is decreasing. So forget about D1. Forget about D2. D2 will be off at least till this time, because till this time Vin is decreasing only. So D2 will be off at least till this time. But when Vin is lesser than 50 volt, D1 will be turned on. Are you getting this point or not? At T by 4 plus we checked that here I am having 99. Vin I am having 99. So across diode D1 what I will be having for this is 99 minus 50, 49 volt. D1 is off. D2 also gets off. D2 also get off. So at T equals to T by 4 plus, first we will write at T equals to T by 4 plus. So at T equals to T by 4 plus, what happened? Okay, let it be there. At T equals to T by 4 plus, we can say Vin is equals to 99 volt let, and Vc1 and Vc2 both are at 50 volt. What will happen? D1 and D2 both are off. Both are off. So both C1 and C2 will retain their voltage because there is no current. So they will retain their voltage. Retain their voltages. Both C1 and C2 will retain their voltages. Both C1 and C2 will retain their voltages. Till what time? The question is, but till what time? So when Vin minus 50, that means Vin minus 50, this potential, when Vin minus 50 is less than 0, when Vin minus 50 is less than 0, what will happen? D1 turns on. D2 still remains off. 2 still remains off. So until Vin is less than 50 volt, until Vin is less than 50 volt, until Vin in less than 50 volt, that means for 100 to 50, D1 and D2 both will be off. Until this is important. Until Vin less than 50 volt, both D1 and D2 are off. And both D1 and D2 are off, that means both capacitors are retaining their voltage. So let's assume this point is 50 volt. This point is 50 volt. So here I should make a line. This point is 50 volt. So till that point, both of the capacitor will retain their voltage to 50 volt. So here I can write both on, both diode on, right? And here I can write both diode off, but let's not write it on the waveform because it will just make it complex. So let's not write it on the waveform. Now we will see when Vin is less than, yeah, so actually electricity went off, so it broke the loop. Yeah, so where we were. So now we are going to check for when Vin is less than 50 volt. So we can write down the time actually, like this time we can write down. This is 50 volt, no? This time we can write down. What will be the time? So that time would be like 150 degree. This would be 150 degree. No, no, no. This is lesser than 90. So at lesser than 90, what should be the time? That should be, let me check. Oh no, sorry, this won't be lesser than 90. This would be 150 degree basically. This would be 150 degree. No? Sine 150 is 0.5 only, right? Because sine 90 plus theta is cos theta, and cos 60. Yeah. So this is 150 degree, and 360 degree is time t. Then what would be 150 degree? 150 degree will be that much, right? So 5t by 12, right? Yeah, so this time would be 5t by 12. At 5t by 12 your input is 50 volt. So this time would be 5t by 12. That you don't need to calculate in the examination, but to write a better theory I am doing it. So at now at t equals to 5t by 12 plus V input will be 49 volt, let. At the next moment V input will be 49 volt. So what will happen? 49 minus 50, diode D1 will get on. D1 turns on, D2 still off. D2 still off. So now D1 turns on and D2 is still off. So what will be the circuit? Circuit will be something like this. This capacitor, now D2 is off, so this will not come in action. This capacitor will not come in action. And since D1 is on, so this will come in action. This was your C1, this was your C2. So what will happen? Now the complete input is exposed to the capacitor C1. So C1 will follow the input until what point? Until minus 100 we are at least sure that nothing is going to happen because the nature is same. Until minus 100, until minus 100 what will happen? D1 will be on only and it will be following the input. After that what happens, that we can see, but until minus 100 the nothing different is going to happen. So till this point, until minus 100, since the nature of the graph is decreasing only, so until minus 100 nothing different is going to happen. So this will be increased only, and this will, sorry, this is VC1, no? So this will follow the input, sorry, this will follow the input. This has started following the input. This will exactly follow the input, and it has reached till minus 100 volt. And VC2, that is not even in action. VC2 is not even in action. VC2, this is not even in action. So there is no current through the capacitor. So VC2 will retain its voltage. C1 will follow the input. C2 will retain its voltage. Will retain its voltage. C2 will retain its voltage. Till now the nature is same. After that what is happening? This time is 3t by 4. This time is 3t by 4. At time equals to 3t by 4 plus, what is happening? Input is some minus 99. At t equals to 3t by 4 plus. Okay, let's come here now. This has followed the input in this direction, right? So it has charged up to 100 volt like this. Now this input is some minus 99 volt. Input is some minus 99 volt. Input is some minus 99 volt. What will happen? Minus 99 plus 100. This will be positive 1 volt. Diode D1 is off. D2 is still off because here it is 50 volt. D2 is still off. To turn on the D2, what should happen? To turn on D2, what should happen? This is V in. Before that, we can write it. Then we can think about it. To turn on D2, what should happen? V in is this much. Let VC1 is 100 volt minus 100 volt and VC2 is 50 volt. So D1 turns off. D2 still off. D2 still off. How D2 will turn on? How D2 will turn on? What will make D2 turn on? To turn on D2, what should happen? That this potential is V in. This potential is V in. So V in plus 100, this potential V in plus 100 should be greater than 50. This potential should be greater than 50 because now your V in is increasing. So you can expect that this potential can increase. Your V in is increasing, so this potential can increase now. So to turn on D2, V in plus 100 should be greater than 50 volt. V in plus 100 should be greater than 50 volt. That means your V in should be greater than minus 50 volt. This is the condition for D2 to turn on. That means until V in is greater than minus 50 volt, both until I have written, that's the important point. Until both D1 and D2 are off. And if both are off, that means there will be no current through C1 and C2. So both C1 and C2 are retaining their voltage. Both C1 and C2 are retaining their voltage. Both C1 and C2 are retaining the voltage until V in is greater than minus 50. So this point is, let's assume, minus 50. So this 100 volt I should write at bottom. They will just retain their voltage till this point. This point is, let's assume, minus 50. Now we need to find this point. What will be this point? Let me find it. Yeah, so that will be, this point will be 11t by 15. Sorry, 11t by 12, because this will be 330 degree. So 360 is a t, then 330 would be, right? 360 and 330. 11 by 12. Yeah, 11t by 12. So this point will be 11t by 12. 11t by 12. So when at t equals to 11t by 12 plus, what will happen? Input will be minus 49 volt. Let V in will be minus 49 volt. And what about VC1 and VC2? VC1 is at minus 100 only and VC2 is at 50 volt only. So here this is at 50 volt and this is at 100 volt. Now this is minus 49. So this potential will become 51 volt. Now if this potential become 51 volt, this will certainly be off only. This D2 becomes on. D2 becomes on. So let's remove it. This also remove it. This also we are going to remove. So D1 is off and D2 turns on. And if D2 turns on, what will be the circuit? The circuit will be, here I have drawn it, or I haven't drawn it. Yeah, this one. The circuit will be like this only. Circuit will be like this only. So this was charged to 50 volt. This is C2, this is C1. This was charged to 50 volt already, and this was charged to 100 volt in this direction. Right? Now your input is going from minus 50 to 0. Your input is going from minus 50 to 0. Are you agreeing with this point? So what will happen? Input is increasing its voltage by 50 volt. Input is increasing its voltage by 50 volt. How do I explain it? It is going from minus 50 to 0, increasing its voltage by 50 volt. Right? Let's take an example. Like, let's assume if I am saying that input is increasing from 0 to 100. This was our input. Input is increasing from 0 to 100. That means the potential here is increasing. Here the potential is increasing. From 0 to 100 it is increasing. From 0 to 100. Now I am saying it is going from minus 50 to 0. That means potential here is increasing by 50 volt. The potential at this point is increasing by 50 volt. That means if the potential here is increasing by 50 volt in this direction, that means the potential in this direction is increasing by 50 volt. Right? The potential in this direction is increasing by 50 volt. That means their potential in this direction will be increased by 25 volt and 25 volt. Are you getting this point or not? Minus 50 to 0 you are going. Look, this is 0, this is 50, this is minus 100. So that means this potential is minus 50. Now you are going towards 0. That means this node is increasing. This node is increasing. That means these potential also has to increase in this direction. That means this will go to 75 volt and this will go to 75 volt in this direction. In this direction it is charging up. So this will go to 75 in this direction. This will go to 75 in this direction. So plus 75 and minus 75 will be equal to 0 volt. Are you able to get it or not? The input is decreasing from minus 50 to 0. Sorry, increasing minus 50 to 0. That means this node is going up. That means these two capacitors will be charged in this direction. In this direction. So 50 volt will be rising up by 25 volt and this 100 volt will be going down by 25 volt because the direction is this. For C1 the potential is plus minus, but it is going like this. So from 100 to 75 it will go. And also KVL is satisfied. Here 0 volt, 75 minus 75, 0 volt. Are you able to get it? So I will again draw the circuit. I hope you are understanding the point that input is increasing from minus 50 to 0. So this C1 will go from minus 100 to minus 75. This is C1. It will increase by 25 volt. This is 100 volt and here it is 50 volt. So input is increasing. Input is increasing by 25 volt. So this will also increase by 25 volt and this will also increase by 25 volt. So here I can write like this. Before writing it, I will show it in the waveform. So input is increasing by 50 volt. So this value will increase by 25 volt. This time we can take up, this time is time t. This time is time t. So at time t, this will be minus 75 volt. And this value will also increase by 25 volt. This is time t. So at time t, this will also be 75 volt. Are you able to get it? The input has increased by 50 volt. So this will also increase by 25 volt and this will also increase by 25 volt. Vin is going from minus 50 to 0, increased by 50 volt. So VC1 and VC2 will also increase by 50 volt, by 25 volt each. Well and good. So these are the waveforms. So finally you can see that your VC1 at time t is minus 75 volt and your VC2 at time t is 75 volt. So that thing that it should be 50 volt or 100 volt, that is eradicated. This is absolutely wrong. Minus 50 and 100, sorry, minus 100 and 200, that is absolutely wrong. Why so? Because that is at steady state. But here we are not talking about steady state. Here we are talking about some cycle, only one cycle. Now it's not that they are going to ask you at 2t time. At 2t time you will have to analyze one more cycle and that will take a lot of time. So till now they have never asked for a cycle. They have always asked the steady state. But if they ask for a cycle, you have the aptitude to analyze the circuit, right? This was only my concern, that if they are asking for one cycle, you should have the aptitude, you should have the knowledge to analyze it for one cycle. And I hope you are able to analyze it now. Well and good. Let's move on to next problem. Or shall we quickly see it? You can see it quickly, right, on your own, that how first it is increasing. First both will increase to 50 volt, then D2 goes off. It will remain off for a very longer time till 50 volt. Then D1 follows the input, then it again saturates, like follow the input, then again saturate, then increases by 25 volt, and it also increases by 25 volt. If you practice this 2 times, if you practice these kind of questions 2 times at least, you will be very quick in solving these kind of problems. Let's move on to the next problem. This problem you have to find the I average. So this will test your basic signal systems, basics of signal systems like average, finding average, and transient analysis. Yeah, so let's start. Or I will take a break of 5 minutes, so I will pause the video. Okay, so let's solve this circuit. So it will test your transient analysis, not the network analysis. So this is the input and you have to find the average value of current. Okay, this is IT, the average value of this current you need to find. So what is happening for 0 to t by 2? For 0 to t by 2, input is 5 volt. Input is coming as 5 volt. So what will happen? This diode will turn on. Open circuit test, complete 5 volt is coming and here 0 volt is coming. So diode will turn on. This diode turns on. Diode is on. And this is 5 volt. This is 1 ohm. Now this is very basic thing that we have studied in network analysis, that if there is a current source across the capacitor, then voltage will be linear, IT by L. Sorry, if current source is there across the capacitor, it will be IT by C. Voltage will be IT by C. And what about inductor? If the voltage source is constant, then what will be the current? Current would be VT by L, right? This we have studied. By simple relation, you can find V equals to L di by dt. So current would be VT by L if voltage V is constant. So here voltage V is constant. So it will drive a linear current, and that current would be, voltage is 5, So it will drive a linear current. That current would be 5t by L. 5t by L, that is 1. So better I should write IL here. IL. And this I am writing IR. So this is our I. So our IT is ILT plus IR. IRT also we can write. So what is ILT? That we VT by L. So that would be 5t by L is 1 Henry plus IR. IR is 5 by R. R is 1. So this is our IT for 0 to T by 2. So this is how our current is increasing, right? This time also I can give. Should I give that? So T you can take as 2 seconds. T you can take as 2 seconds. T is 2 seconds. So linearly it is increasing. So what will be I value at T by 2? T by 2. It would be 5T by 2. So 5 plus 5. That would be 10 ampere. Are you getting this point? I just put T by 2 here. So T value is 2 seconds. So that would be 10 ampere. So I can draw the waveform of IT. From 5 to 10 it is increasing like this till T by 2. After that the interesting point comes. This is T by 2. 5 ampere and 10 ampere. At T equals to T by 2 plus, what is happening? V in is gone. V in is 0 volt. But the current in the inductor is set up 5 ampere. So that is not going to change instantaneously. This inductor 1 Henry inductor is having 5 ampere current. The input is gone. Input is gone means that input is shorted. There is this diode and there is this resistance. Now you must be confused whether this diode will be on or off. Look, this is 0 volt, this is also 0 volt, and here if I apply open circuit test, this will also be 0 volt. 0 and 0, usually at 0 0 I turn on the diode. So even if I turn on the diode, what will happen? Let's assume I turned on the diode. I turned on the diode. So 0 voltage, this 0 voltage is coming here. So the resistance is there in between 0 voltage. That means it is driving 0 ampere current only. So is there any use of it? Even if I turn on the diode, the resistance is having 0 voltage. So it is driving 0 ampere current only. So is there any use of it? No. So you can simply make it open circuit or you can remove it. Basically, there is 0 ampere current flowing through the resistor. So you can replace the circuit like this. Now this is a network analysis problem which I have taught in the network analysis playlist, but here also I will tell you. This was our IT, right? This was our IT. This is ILT. Now my question is, what will happen to ILT? First option, it will go from 5 to 0. This is the first option. Second option, it will remain at 5 ampere only. What will happen to ILT? And ILT is same as IT only. So what will happen to IT? It will go from 5 to 0 or it will remain at 5 only. This is my question. Don't apply Laplace transform. Think about it. Don't apply Laplace transform. It will remain at 5 ampere only. What is the equation? IT is Vt by L plus initial current. IT is Vt by L plus initial current. Initial current is 5 ampere. Now the new input applied, that is 0 volt only. What will be the current? 5 ampere. So it will remain 5 ampere only. Are you getting this point or not? Understood? So it will remain at 5 ampere only. If you are not able to understand it by this point, apply Laplace transform, because Laplace transform, if we apply Laplace transform, everyone will be happy. So what will happen? This inductor will be replaced with S, and then in the direction of current minus to plus, this will be 5, right? L into I. I hope you are comfortable with Laplace transform at least. So this is how we will make the battery, that is 5 volt, and this is replaced with S only, and then we have to find the ILS. So what will be your ILS? ILS will be 5 by S, and what is 5 by S? That is 5 ut. So the current is constant only, the current will remain at 5 ampere only, so it will not go down, the current will remain at 5 ampere only. This current at T by 2, it comes to 5 ampere because there is no current in the resistor. It comes to 5 ampere, and then it remains at 5 ampere only. Actually, I am really sorry, I need to change the question because it's not possible to find the I average. The question should be plot IT. Plot IT. I have to change the question because in the next cycle what will happen? So this is happening from T by 2 to T. This happened from T by 2 to T. So T by 2 to T. All this happened from T by 2 to T. Now in the next cycle what will happen? At T equals to T plus, what will happen? Again input is coming, that is 5 volt, but still the inductor is having 5 ampere current. Input is coming, that is 5 volt. Now the inductor is having 5 ampere current, which is this 5 ampere current, and 1 Henry is there, and this diode will be on now. Diode will be on because of this 5 volt. Diode will be on, and this is the resistor, which is 1 ohm. So now this inductor is initially having 5 ampere current. So what will be this IT current now? So this IT current would be this 5 ampere current which was there initially, and because of this resistor this 5 ampere current is coming, so that we will write later on. This 5 ampere current plus the new inductor current because of this 5 volt battery. Look, inductor is initially having 5 ampere current. Now you are applying a voltage source across it. This is the question. If you are not able to grasp it, the first thing is that you are not good with network analysis. Okay, if you, देखो बुरा लग रहा है तो लगने दो, लेकिन अगर आपको ये चीज नहीं समझ में आ रही है कि पहले इनिशियल करंट है फिर उसमें वोल्टेज आएगा तो वी टी बाई एल ओवर ऐड कर देंगे, तो आपका नेटवर्क एनालिसिस वीक है. अदरवाइज यू कैन सोल्व इट विद लाप्लास ट्रांसफॉर्म बिकॉज most of the students solve from Laplace transform only. But if your concepts are clear, you would know that okay, 5 ampere current is there. Now you have applied constant voltage, so again 5t by L current would be developed. L is 1 Henry only, so I will not write it. And since we are starting from time t, so better I should write t minus t. So I should write 5t by L, 5t minus t by L, and plus this 5 ampere current, this 5 ampere current. So what will be my 5 IT at 3t by 2? That would be 5 ampere plus 5 into t by 2. Time t is 2 seconds, so it will be also 5 ampere plus 5 ampere. So it will be 15 ampere. So you got to know that in every cycle inductor is taking up 5 ampere current. So how will your final waveform look like? This I can copy and let's make it on next page. What happened was, so here initially at time t you are having 10 ampere current again you are having 10 ampere current because resistor is driving the current again, but from 10 to 15 you are going now, 10 to 15 ampere you are going. This is 15 ampere, and this time is 3t by 2. This time time is 3t by 2. Now this inductor has taken up 10 ampere current. This is the inductor current that has taken up 10 ampere current. So at 3t by 2 plus, what will happen? This inductor will retain its current. This will be shorted. There is no use of resistor current. So this inductor, 1 Henry inductor that is there, it will retain its current, that is 10 ampere. So this inductor is retaining its current, that is 10 ampere. So again it will come down to 10 ampere. It will come down to 10 ampere and will remain there. Then in next cycle, what will happen? This is 10 ampere. In the next cycle, what will happen? Immediately at t equals to 2t plus, what will happen? This 10 ampere current is already there. So what will be IT? 10 ampere current is already there. It will set up another 5 ampere current, t minus 3t by 2. Since we are starting from 2t, no? Yeah, we are starting from 2t. So I should write 2t here. Starting from 2t, I should write 2t here. Plus 5 ampere, this is a resistor current. This is a resistor current. So I should write this is resistor current. And this is inductor current. So initially 10 ampere at 2t, this current is not there, which is building up slowly. So 10 plus 15. So again it will rise up to 15 suddenly, and then go up to 20. So in this manner it will keep on going, go up to 20. This is 2t, this is 5t by 2. The waveform will keep on going like this. Then suddenly it will come down and again 15, then again go up. So 5 ampere it is building up. Are you able to see the waveform? So this is how your final IT waveform will look like. Since it is keep on increasing, we can't find the average value. Well and good. Satisfied with the answer? Okay, this was actually based on network analysis only. This is the concept of transient analysis only. First 5 volt is there, that means resistor will also take up current, inductor will also take up current. 5t current is taken up by inductor and 5 ampere current is taken by resistor. So in 1 second it will reach 10 ampere current. So this is what it is reaching, 10 ampere current. Then suddenly the input is gone. So there is no current in the resistor, only the current is there, that is in the inductor, and that 5 ampere current will keep on flowing in this loop. It will keep on flowing in this loop. Nothing will happen with that 5 ampere current. So 5 ampere current remains there. Then what will happen? Again 5 volt is coming. So again you are having 5 ampere current, 5 ampere resistor current, so 10 ampere current is there. Now because of this 5 voltage, inductor will take up more current. So from it will take up 5 ampere current more. So linearly it will rise. So that's how it will linearly rise to 15 ampere. Then again input is gone. So this 10 ampere current which was there in the inductor, that will keep on revolving. So 10 ampere will be there. Then again input is back. So 10 ampere current plus 5 ampere resistance current. So 15 ampere and then more 5 ampere current inductor will take linearly. Then again it will go to 15, then remain at 15, then suddenly go to 20, then 25. Then come back to 20, then remain at 20, and suddenly go to 20 and then 35. Sorry, then 30. Okay, so that's how it will keep on going. So this is the final waveform of IT. So at any time they can ask you the value of like at this point they will ask you what should be the value of IT. So you should be able to write down that. Let's move on to the next problem. So this is a very simple problem. You have to tell the final V out waveform. So what should be the final output? Option C, right? Why so? Let's check that. Let's assume this point to be grounded. So if it is 0, here positive supply is coming. If this positive supply is coming, we are not sure whether this diode will be on and this diode will be off. Why so? Because we don't know the potential of these points. If you apply open circuit test, you don't know if this is grounded. No, you don't know. You don't know anything. So you don't know the potential of this point. So you have to apply short circuit test here. So I will apply short circuit test here. So I am assuming this diode is on. This diode is on. So if this diode is on, what will happen? This positive supply will travel. It will travel like this, it will travel like this, it will travel like this, and will reach here. Are you getting this point or not? When Vin is positive, what did I do? When Vin is positive, I don't know the potential of this point, I don't know the potential of this point, I can't comment anything. So I assumed that this diode is on. This I am calling D1, this I am D2. So I am assuming D1 is on. So if D1 is on, this will travel like this. It will travel like this. This positive voltage will travel like this. It will reach here. So here you are having some positive voltage and here you are having 0. That means D2 is also on. So if D1 is on, D2 is certainly on. So you can conclude that when positive supply is there, both D1 and D2 are on. So if both D1 and D2 are on, what will happen? So this positive supply is Vin only. So this Vin will reach here and this 0 will reach here. So V out is equals to minus V, because here you are, this positive is there and this negative is there. So V out is equals to minus V. So when V in is positive, your V out is equals to minus V. Now in the next cycle, what do we do? Something negative is coming. So this is ground only. We can't change the ground. This is negative. Now here negative is reaching. Now you don't know whether the diode is on or off. So what you will do? Let's assume diode to be on. Let's assume D1 is on. If D1 is on, this negative will travel and reach here. Right? This negative will travel and reach here. So here you are having 0 and here you are having negative. That means D2 will be certainly on. You assumed D1 to be on, but you got to know that D2 is off. Right? So if D2 is off, still let's assume D1 is on. Let's assume D1 is on. If assuming D1 is on, D2 is off. So if D2 is off, these 2 points are off, then what will happen? This negative, and I am assuming D1 is on. So this negative potential is traveling. It will travel here. There is no path. This is on, this is off. So it will travel like this. And it will travel till this point. So V out will be 0 only, because whatever the potential you are having here, the same potential you are having here. Let's assume this point, this value is minus 3. I am assuming D1 is on. If I assume D1 is on, D2 is certainly off. D1 is on, then I got to know that D2 is off. Minus 3 is reaching here, D2 is off. Now still I am assuming D1 is on. So if it is on, minus 3 will reach here. Then also there is no path for 0 to come. There is no path for this 0 to come. So only this minus 3 will travel here. So both potential are equal only. Are you getting this point? Both potential are equal only. Some people say that for negative cycle, D1 and D2 both will be off. But you can't comment that. You can't say that. One of them will be off. And if one of them is off, then you can certainly say that V0 will be 0. That's why in these kind of question, they will never ask you the operating condition of D1 and D2. You can predict the operating condition of D2 if you know the operating condition of D1. First, we assumed D1 to be on. If D1 was on, for the positive supply, if D1 was on, we saw that D2 was also on. Then we got to know that V0 is equals to minus V. For the negative supply, if I consider D1 to be on, D2 is off. That means 0 cannot come there. So V out will have whatever the potential you are having here, the same potential you are having here. You can't say that here I am having 0 potential and here I am having 0 potential. No. You can only say that at the both of the node, at this node and at this node, I will have the same potential. This is what you can say. And if the same potential is there, that means V0 will be 0. That's it. These are the comments only you can make. Understood? So yeah, many times we get the final answer, but conceptually we are wrong. So here we are making it conceptually right. So V0 is 0 volt and here your V0 is equals to minus Vin. Which is that cycle? V0 is equals to minus Vin, then 0 volt. Option C is correct. Well and good. So we have completed our diode circuit. So diode circuit is complete, right? After that, we have to study diode circuit. Diode was a 2-terminal device, right? This was a 2-terminal device. 1 terminal and 1 more terminal. Now we will study 3-terminal and 4-terminal devices. 3-terminal device is known as BJT and 4-terminal device is known as MOSFET. But I need to think first I should teach you MOSFET or BJT, because for EC and instrumentation guys, MOSFET are the most important, and for VLSI interview as well, or M.tech interview, everywhere MOSFET is asked. For BJT, amplifier portion is not important, but biasing portion is important. Like they can ask you question from biasing. It is very rare that they will ask you question from amplifiers, but they can certainly ask you question from biasing. So biasing part is important for BJT also, and MOSFET is completely important. So I will take a call. I will think about it whether I should start MOSFET or I should start BJT. Okay. So I am pretty sure that you found this diode circuit playlist very helpful. So please try to share it with everyone so that they get to know that what kind of content is being taught here. Okay. Thank you.